we're going to be trying to use is called Jupyter notebook. And what's nice about this is, I mean, conventionally, when you develop a lab, like hands-on lab, it's usually on a piece of paper. So it's very difficult to edit, and if you want to make some quick last-minute changes, you have to print the whole thing all over again. And then another issue with that is also it's very static, right? So students really have to follow things step by step, but they don't really have the capability to run something the way things are presented in the lab. So what's nice about this one, I mean, we'll have a hands-on opportunity with this, so you'll be able to do this, but what's nice about this is that you can actually run the live code within the lab document environment. So it's very exciting. So I'm going to hand this over to Tyler, who's been working very tirelessly to set up the server and get everything ready for our hands-on today. So Tyler.
Thank you. Hi, my name's Tyler, and I'll show you how to use Jupyter Notebook. What is Jupyter Notebook? It is a web application that makes sharing notebooks or documents and code extremely easy. It also uses live code without the worry that it will not be able to work for everyone else. So you'll be able to share code with anyone and have it work in that kernel, I guess, and it'll work for everyone who uses it at the same time. There are several different ways to install it. The first is to use Anaconda, and to do that you would have to download it from their website through just Googling Anaconda and then downloading it straight from the first result.
So so a little bit later we can actually show you what it looks like from his laptop. So what's nice about it is you just download this very self-contained environment, so you can run everything on your own machine. Another option is called Jupyter Hub, which is sort of a server solution. So nobody has to install anything on their computer. Everything can be done in a web browser. So actually we set up your accounts already, and he must have handed out this piece of paper with the credentials. So we have this server already, Jupyter Hub, Jupyter Notebook Hub server up and running right now. So that's what we're going to try to do.
Okay, so to launch the server, just go to that URL down at the bottom, the https //52.34.
So if you have your machine right now, I want you to go to that IP. So we do have a domain, but it's actually much, much worse. So this is kind of a little counterintuitive, but the domain name is actually worse than the IP address. So that's why we're using the IP address. So yeah, if you can sign on to 52.34.38.19.
You may have to go through the event since the certificate wasn't signed by...
Yeah, so I can show you some things. So what happens is, let's see. So this is what you're going to see when you sign on, because it's not because the website is insecure. It's because we haven't installed a proper so-called digital certificate, but you have to pay for it, so we haven't done it. So that's why. So if you see something like this, basically at the very bottom it says proceed to so-and-so. Just click on that. Then you'll be able to sign on. And then so this is what you should be seeing when you click on the link and all that. So there you just type in your credentials, username and the password. And what happens is basically so this is what you should be seeing. Is that better? Yeah. So if you're not at this stage, let me know because you need to be able to do this. Yeah. But you can take over from here. But I guess you can show them how the document. Yeah. So let's wait to see if they have all these things figured out. So is everybody okay? All set? Okay, so you go.
Okay, so the next part, I'll just take you through a demo on how to make a document and some of the normal formats you would likely use it. So just go to the file named anyone, since that's where we all have permission to make files right now. And then go over to the sidebar and select new, and any notebook will do. I'm going to use Python 2.
So one thing I'd like to add here is that the whole thing, the environment supports a particular language. In this case, it's Python. So let's say you want to create a lab, a live lab that can run within this environment. Right now, what we can support is only Python. So it's mostly for, I would say, Python programming, but is there anything else being supported?
There's many other smaller programming languages similar to Python. I think JavaScript and stuff like that supported by it.
So, but a lot of things we do right now is really Python based. The data science ones we're actually creating, the labs, so we have no problem. So let's say that you're an instructor and trying to create a lab using this environment. It has all the things you need. I mean, for example, in order to enter the text, you can do it. And actually the elements of the document, they're called cells. So you can create a cell with a text, you can create a cell with the code. The nice thing about the code cell is the fact that you can run the code within the document. So that's what's really cool.
Yep. So as you were saying, you can run the code. So you should see a cell that has IN instruction with the square brackets, and you can type into it like normal Python code. So, for example, print.
So he just ran the code basically. So
yeah, the output's right below it.
you want to show it?
Yeah. So the output's right below the cell when it runs, and as you can see, it prints the statement that we provided by it. Hello world. There's two other types of cells that you can use. The first one being the markdown cell, which I will demonstrate you that cell right there.
So if you want to do something fancy, like using HTML to make your document look prettier, you can use this thing called the markdown cell.
I can do an example of HTML.
Yeah. Just do an HTML. So as you can see, the text just showed up with red color.
And I can just do this cell. And for this cell, that's a raw cell, so it won't actually run HTML. It'll just hold the data as raw data.
Right. So if you want to just show the HTML code as part of your lab, you can do that too, I guess. So can we create, say, a lab title at the very top of the document? So lab 0, whatever. Yeah. Let's try.
Lab 0?
Yeah. Lab 0 as our title.
So do that. Markdown cell, and then you use hashtags to make the header any size that you would want. You want to do a default header. So let's name it lab
0.
lab 0.
Yeah. Yeah. So that's your title of the lab. And let's say I want to add some additional instructions in the very beginning. Let's say I want to have a section, introduction section in the beginning. Can you just add some text? Yeah. So you can do whatever you want with the document, but once again, what's nice about it is it's very dynamic, and you can change whatever you want right there whenever you need to make these modifications and so on. So another plus is you can actually run the code. So let's say the lab was to do this hello world kind of exercise. That's your lab right there. And another nice piece of advice, not really advice, but another nice feature of this is that you can let the students download this lab onto their own machine, and they can actually make the modifications and run these types of things on their own machine too. So you can actually have the students do some additional challenges, for example, with the base code you're providing.
You can also use variables in different cells, so you can like define this equal to 1, and then you can use it later on in other cells as you need to also.
Yeah, so what's nice about it is again, throughout the document, basically all the things we're doing, they're persistent, so the program actually remembers everything, and it treats the whole thing as a single, I guess, program in this case. Yeah. So I'd like you to maybe create your own lab, whatever lab it is, for maybe like 5-10 minutes, and we'll see how you're doing. And then what we can do is I can also show you one of our completed labs that was done using this Jupyter notebook, yes.
So Weka is a data mining / machine learning program that makes it extremely easy for users to use big data, basically. So you can easily to download it, go to their URL at their website to download it. It's pretty big, so I don't know if you'll be able to download it over this Wi-Fi. It's 110 megabytes about. Download it with Java, so it's a good bit.
So what we wanted to do was just to have you be able to download the tool and actually try it out. But if you are able to download the tool and try it out, I think it's all good. But you can also see just the demo of the tool. So Tyler already has the tool downloaded on his machine. So we can take a look at his demo first, and let's see what happens with the one you download.
So you might be asking, what is Weka? Weka is a machine learning program that runs on Java. It is capable of using predefined algorithms, machine learning algorithms, to predict outcomes for certain data sets, either a CSV data set or like their special case data set, which is an ARFF data set, which you can convert from CSVs and other different types of, many different types of data sets. It's a very easy to use interface and very user friendly, since it's all based with their GUI that they ship it with. Can also be used in programming though, so this makes it extremely useful in automation and using it to automatically detect vulnerabilities and network intrusion and other stuff like that.
Yeah, so what's nice about the tool is, I mean, let's say you don't know anything about machine learning. It comes with this library of all the machine learning, well-known machine learning algorithms. So you don't really have to do any programming. All you have to do is really point and click. So you pick and choose what machine learning algorithm you want to be using to solve this particular problem you have. So one of the problems we were going to show you today was this ability to tell whether somebody is a Democrat or Republican based on some of these attributes, and the attributes are of course stored in a data set. So he's going to do a little bit of demo of this machine learning algorithm figuring out whether somebody is a Democrat or a Republican. And then the nice thing about this is also that the data set is tagged, so we know already the answers, right? So that's how we can test the accuracy of the algorithms. So it's going to do a little bit of demo of that, right? So, yeah. That's a little slow. Yeah.
So first thing that we're going to go to is the Explorer tab, since that's where most of your algorithms are easily available.
So when you start the program, that's what it looks like, and he just clicked on
Explore.
Yeah, Explore, and you get into the environment. That's what it looks like.
So here you want to open your data set, so you can go all the way to where you have it stored. They come pre-built with several different test data sets, which we are going to use today in their Weka folder for program files. Weka 8 data, and then there, vote.
So that's the file that contains all the data about people's attributes related to the decision of whether you're a Republican or a Democrat. So,
Yep.
so when you open it up, it looks like that. Yeah.
And you can see all the different ways that they classify or what they voted on in the
Yeah.
past, and they have who voted for what, and they use that to use that in the algorithms to make the predictions.
Yeah. So basically, you see if you voted on immigration and whether you said yes or no, in that case, it uses that as one of the criteria in making a decision on whether you're a Democrat or Republican. And
Okay, so now we can classify this data set. So we go to the Classify tab.
can you go back this one? So here we have how many attributes do we have? 17 attributes?
17, yep,
Yeah.
and 435 people for different types of people.
Yeah, so basically you voted on handicapped, infants, water project cost sharing, adoption of the budget resolution, the list goes on and on, but basically based on your voting record, you're trying to make a decision on whether you're a Republican or Democrat. I don't know whether you have a choice of being somebody in the middle, but in this case it's either Democrat or Republican. Independent.
So we'll just use the first one that they come up with, which is 0R, and we'll hit start to classify using cross-validation.
So it's an algorithm, classifier algorithm, machine learning algorithm. He just chose to do the job in this case.
Hit start, and then it comes up with their prediction. In this case, it put all of them selecting as Republican or Democrat. So we have 61% being classified correctly, while 38% is wrong. And this really isn't a very good classifying way, since it just chooses one attribute to base it all off.
So the algorithm worked, it ran, as you can see, and the performance is not that good, right? Because we only classified somebody as a Democrat or Republican correctly with the accuracy of 61%. So this is not good. But this is why we have multiple algorithms, machine learning algorithms. So you can pick and choose to see which is really the best one for this kind of job. So that's the power of, I guess, the tool, because you can pick and choose and run different algorithms and until you get the kind of accuracy you want, until you know the algorithm actually works.
Do you consider significance levels such as 95, 98, 99?
Yep.
I don't know.
You can do experiments.
Yeah.
That would be in the experimenter tab. You can do stuff like that. In the Explorer tab, I don't think they have that type of data output. They have the kappa statistic. They have all this other fun stuff.
Yeah.
Because in the statistics mentioning significance,
Yeah.
with kind of
99%, 95%.
That's more in the Explorer tab that you can get into that type of detail. That's back at home, and we're in Explorer, but that would be more in the experimenter.
Can you go back? So
This one?
yeah, so you can see out of how many was the total?
435.
Yeah, it was like 435. The sample size was 435, and out of 435, 267 was classified correctly. So let's try to use a different algorithm and see what happens.
Let's use J48, since that's basically Java's main go-to algorithm that they use all the time. And there, 96%.
So now the accuracy went up drastically. So now it's at 96%.
Yep.
Yeah, so out of 400, how many was that? 35. We got 419 correctly classified as either Democrat or Republican. So this, I mean, so you can see, depending on what kind of algorithm you're using, the results change quite a bit.
Do you do second level of interpretation and using different averages and going up? And the average of the averages?
So that's the implementation, because I don't really know too much about how they implement those types of things. So, Professor Lee, do you know anything about?
I'm sorry, I didn't hear the question.
Just we are using different algorithms, machine learning algorithms.
Right.
So using different algorithms, we got some slightly different results. Can you think of the second level of algorithm, machine learning algorithm, considering all different results?
So there are general technique called the ensemble, essentially using the multiple algorithms as a baseline, and then try to use the best of it. And then there are different the types of the ensemble techniques like boosting, bagging, and so on. I think some of them are implemented here too.
So there is a way to still build on
Right,
your
right.
initial experiment.
So if this is to be used in the computer science undergrad kind of course, where students are capable of coding some of the algorithm, I think you can have them implement some basic the algorithm on their own, link it to this tool, and then they can use this GUI to run their own algorithm. If you use this in the high school kind of a course where students not really able to code, then instead of asking them to implement their own the algorithm, maybe the focus more on the feature engineering part, which is probably more important in the data analytics. Because here, data set is very clean in the sense that all the attributes are identified, and then the values are already clean there. In real applications, often those are not the case. Data comes from the multiple sources. They are really dirty. You're not sure which features are important or which one to use. Right? So the when you talk to the data scientists, they say bulk of their time is spending on the data cleaning and the pre-processing, followed by the feature engineering. Once they finish that, actually running the algorithm and the following step is substantially small. So students really need to understand the pre-processing and the feature engineering part.
Do you consider also hypotheses?
Right. Yeah. So I think if you go to this website, they have some of the case studies some of them show that how to come up with the hypothesis, and then using some of these tools to defeat the null hypothesis and so on. So they show that.
Sense like 99%.
Right.
Specify different kind of
Yeah.
values.
We can use the different confidence intervals.
There is, I guess, configuration part where you could make all those adjustments. So another nice thing about the tool is, so let's say you're like a true end user, and all you can do is really point and click. So Weka is really good for that, I guess, in terms of doing machine learning related activities. However, let's say that you're more like a developer type of person who prefers dealing with Weka using your programming. So if that's the case, we can actually access the application programming interface of the tool, API. So we can actually do everything without the GUI, graphical user interface, just by using something like Python. So one of the labs we created using Jupyter Notebook is actually doing that.